Hello, everyone. Can I have your attention, please? I hope you had a great keynote today, and you had some coffee. I'm pretty happy with the weather today. I'll be honest. Like, I am coming from the south of the India, and for the past 2 days, I was literally shaking too much, and I was trying to figure out how I'm going to, survive these 2 days. But hopefully, I survived these 2 days with the coffee. But yeah, so we'll start with our talk today. We will be talking about your Kubernetes playbook at your fingertips. Quite an interesting topic when I was talking with David, what should we put out, and we figured out, okay, there is a much more better way coming up, and there is a project called KGPT. To use MCP with Kubernetes to troubleshoot your Kubernetes environment or the production. So we were experimenting with the project, and we have done some of our work, and today in our talk we'll be sharing about it. So I think, so let's start with our introductions. I'm Yash. I work at DigitalOcean as a developer advocate. I'm also a maintainer of a CNCF project called Mishri. It's a cloud native manager. I've been contributing in CNCF for the past 3 years, and in a many ways, like through the events, contributing through the projects, and many, many things. I'm also an open source contributor, not only in the CNCF ecosystem, but outside of the CNCF ecosystem as well. I love machines, any kind of machines I love. And there's one fact I came up with is like the Firefox logo isn't a fox, if you don't know. So it's actually, it's not a fox. And I'll introduce to David. Hey, David. He used to be my colleague, but would you like to introduce?
Yeah, for sure. So hey, my name's David vonThenen. I work at NetApp, so I'm in the office of the CTO. I've been doing like AI, ML stuff for like a number of years. Typically focused in NLP, so that's natural language processing. Prior to that, I was actually in the Kubernetes and CNCF ecosystems, working on open source Kubernetes at VMware, and also at EMC, so that kind of dates me how far back it goes. But yeah, no, happy to be here with Yash here doing the talk, and yeah, let's jump into it.
Okay, thank you, David. Let's jump with the next one. Okay, so what is KGPT? How many of you are aware of this particular project right now in the CNCF ecosystem? Oh, quite a many people. So those who don't know, this is a project which is helping you to troubleshoot your Kubernetes cluster, analyze your Kubernetes cluster with the help of AI. AI is coming up, and we all know that it's been a decade that Kubernetes came up, and now we all are figuring out, right, to run AI workloads in the Kubernetes, or sometime how to train AI workloads in the Kubernetes. KGPT focus on how you can make your process of troubleshooting Kubernetes easier with the help of AI. Get you better suggestion, how you can improve, or what's the error you're getting. So it helps you troubleshoot your Kubernetes cluster with all of things, like you can use your backend API on your own. You can run on your own models on it, local models, or the available models like the default models like Open API or the Amazon Bedrock, and many other models that you can use with it as well. Now, if I come to that, like the next, what are the use cases I was talking about? The main use case is making sure the troubleshooting is quite easier for you, and the suggestions are easier. Like when I started in the Kubernetes, I used to get very weird errors, what this error means, and what is the suggestion, how we can improve upon it. So this is one of the main core feature of the KGPT. And the second thing is, when I was checking, I also figured out that you can also use it in your GitOps workflow. So if something goes wrong with your deployment or something, KGPT can help you analyze, okay, what went wrong, and how you can improve upon it with a lot of suggestions as well. So if we move forward, I'll ask David to talk more about what we are going to talk, or a demo on the RAG.
So kind of like the premise of this talk was like, hey, KGPT, you can use it to like troubleshoot Kubernetes clusters, understand Kubernetes better, like what's going on with my pods. And then, of course, with all this AI stuff that's happening, like how do you combine the two? And CacheGPT, like Yash is saying, under the covers, uses large language models local or in the cloud to help debug and troubleshoot that. But what's really interesting about that is that there's a prescribed, several prescribed security profiles that CacheGPT ties into. But with every organization's different, right? You have your own security rules, your own best practices. And so kind of the idea was, how do I get those best practices, that information, into my workflow with CacheGPT to troubleshoot problems that are specific to like the policies and the RBAC and like even naming conventions for how your Kubernetes clusters operate and work together. So who here is in IT and who here knows what a runbook is? Okay, yes, awesome. I'm talking to the right crowd here. So for those that aren't familiar with what a runbook is, so a runbook is basically a step-by-step guide to do everything from troubleshoot your Kubernetes cluster or any kind of IT process. But since we're at KubeCon here, specifically your Kubernetes cluster, and it's meant for people who may not have like super power Kubernetes expertise and knowledge. And so it's kind of geared for everyone. What happens when something goes wrong? And what happens when I need to fix this particular problem? How do I diagnose it? What are some things that I can, like logs, what are things that I can collect? And so your runbook at your organization has very specific characteristics and policy enforcement and even naming conventions that kind of define what I need to do when something goes wrong. And it even contains normal operational stuff too, right? If I'm looking to deploy pods or deploy, do Kubernetes deployments, what does that look like? How do I set up my YAML so that it reflects those business rules and that, and those policies? And so kind of the idea here is like, hey, if we want to take that playbook, that operational playbook, and then kind of imprint it into our workflow for troubleshooting Kubernetes clusters using CacheGPT, like how do we go about doing that? So this is kind of like a walkthrough of what that will look like potentially, just like kind of like a POC, just a proof of concept for how you can imprint your Kubernetes playbook onto your AI process to troubleshoot using CacheGPT. So why would you want to do this, right? So sure, you have your runbook, it's great. Hopefully it's up to date, right, with the ever-changing releases of Kubernetes. But why would you ever want to do this? And just like the whole idea about like RAG agents kind of give you an awesome tool, like a live running tool for being able to query your documentation using natural human language and be able to like have a dialogue or discussion with your playbook, which sounds like a crazy concept, but that's kind of like what the whole point of a RAG pipeline is. And so your runbook, your playbook, becomes a living document, something that you can talk to and query. And it kind of bridges the human element to the very technical documentation that's contained within your runbook. And so it could help you with generating YAML. Like if I need to generate YAML for a deployment, like what does that look like? And your agent then, because you have imparted this knowledge for your playbook onto your LLM, your agent starts to think like your organization. And that's kind of the key part for this, this talk and this discussion and this proof of concept. And kind of Yash was saying that you can use CacheGPT for all sorts of things, retrieve metrics, pull logs, information, kind of profile what's happening, and then take that information and then be able to create your own, take your profile and then create your own remediations based on your playbook or your runbook. And so that's kind of the idea behind this session. And without any further ado,
okay,
we're going to go ahead and demo something here. But before we do that,
Awesome. So as we were discussing, like why we are going with the approach, one of the things was like David mentioned, it is important that right now with CageGPT you can get the analysis, you can get the remediation, but it's not always what we want because it's not aware, like the models are not aware of your policies, security policies, which you do in your organization, right? So David created this repository, which will help you go through it. Like you can take it as a home resource to go and check out as well. So this is a quick repo where you can learn more about what we have done, created the RAG agent and how we have done it. You can check out the README to understand it better and how you can run it locally as well. So in the materials, we have a playbook, which is a simple playbook which we got, so that our RAG agents can use it. And if we go inside the demo part, inside the source part, so we got agents in the client, ingest for the embedding, and the MCP server as well. So CageGPT comes with own support of MCP as well, which you can connect with the cloud. We'll go talk about this as well. But for now, I hope you get the idea of the repository. And now we'll go with the demo and some nerdy stuff. So I'll ask David to do that. And let's see. Let's do some live demo.
Because what could go wrong, right?
Yeah, let's hope demo God is with us today. Or let's see.
So I already have a Minikube cluster, and it's just for simplicity so that you can reproduce this on your own laptop. That repo is open source. It's there. It's exactly what I'm going to run right now today. But so I've already instantiated your Minikube cluster on my laptop here, so Minikube start. And I've already applied the kubectl config so I can like run kubectl commands against that cluster. So the first thing we're going to do, right, is we let's go ahead and take a look at this. So that document, and I'm probably going to get put on some awesome watch list. So this document's actually a real runbook for the NSA. Don't ask how I got it, it's all good, but it is. It's a 66-page document about how they prescribe to do Kubernetes clusters. That PDF is in the repo. Hopefully I will see you later on this week. So we're going to use that and because it's in the repo, I've coded it so that it will use that. And we're going to now take that PDF file, right, that Kubernetes hardening best practices by the NSA. And what we're going to do is we have an existing, and we're using Claude. It could be any LLM. It could be local, but just for simplicity purposes, we're using Claude in the cloud. And we need to impart that LLM with the knowledge of that runbook. And so the first thing we need to do is we need to generate vector embeddings, right? Chunk the document so that we can have like little bite-sized pieces that we can reference, do vector similarity search, so that when we ask it questions, our RAG agent, that we be able to get specific parts of that document so that we can pull that information and say, hey, if I'm doing X, Y, and Z, use the correct embeddings to map to what I want to do for that particular question. So let's go ahead and do that right now. So we're going to do make ingest. And we're going to take that Kubernetes hardening guide PDF, chunking it in 170 chunks, do the batch processing, and now we have the vector embeddings right here, which is that Chroma DB. So local vector embeddings on the laptop here. So now that we have the embeddings generated, right, so we've chunked the document, and we now are going to use those chunks to impart knowledge about our organization, the NSA, into our pipeline here to be able to query that agent using the best practices for the NSA. And what we're going to do next is we're going to start a MCP server, and behind that MCP server, who knows what MCP is? Okay, cool. For those that don't, MCP, think about it this way. It's just a natural language interface that you can speak in whatever language. Most people, because of compatibility reasons, especially because of our documents in English, we're going to go ahead and we're going to talk English to an MCP endpoint. And under the covers for MCP, it's going to go ahead and be able to query certain things. And one of the things that we're set up to do is to use CageGPT to say, what is the status of my Minikube cluster? And like is everything okay with what's happening in the cluster and the pods there? The second thing we're going to do in that MCP server is also just do additional kubectl commands to basically get some state, like metrics, information from that cluster to just do some analysis side by side with that KHGPT CLI tool. So let's go ahead and do that right now. Let's start the MCP endpoint. And MCP, the way it works, there are many protocols that are being used. The default one and the one that most people use is server-side events, so it's a streaming interface. And so you can see here the KHTP CLI and then the kubectl CLI. And now we have an endpoint that we can talk in language to in order to invoke these tools. So the next thing we need to do is we need to have an LLM to talk to the MCP endpoint. And what we're going to do is we're going to go ahead and we're going to start our RAG agent. So we're going to take the embeddings which are contained in ChromaDB here, and then we're going to start an agent that has access to those embeddings. So let's go ahead and do that right now. So you can see here Claude Sonnet, right? Claude in the cloud. That rhymes, didn't mean to do that. And you can also see that we have an endpoint that we can query against this server REST endpoint with the RAG agent underneath. And you can also see, if we switch back to the other console, that we have this 200 OK call so that we have the agent being able to communicate with the MCP server. So the MCP server has advertised its capabilities, the tooling that we're providing to our agents, so that our agent can invoke that tool. So now what we're going to do is we're going to create a pod in our Kubernetes cluster. So it's a very simple pod, and it's just for demonstration purposes. And we can go ahead, maybe if I can catch it in time. Oh, it's already running, but you can see that I just started it 8 seconds ago. So now we have a pod in our cluster. Now we want to be able to ask it questions. And in this particular case, I picked out, obviously, a question that is related to that CIA runbook for Kubernetes. And the question that we're going to ask it is, I forgot to load this out. So using KHGPT, analyze the cluster and report any workloads where the security context allowed privilege escalation is set to true or unset. And conclude pass if none are found, and then otherwise fail. And so kind of the idea is we can, in plain language, give a prompt to our RAG agent that has the embeddings for that runbook, and then invoke tooling through MCP to invoke KHGPT and normal Kubernetes cluster commands. So without any further ado, let's go ahead and run that. So make client. And this is going to the client for the REST call. It's going to call that server endpoint, which has our embeddings and our RAG agent talking to MCP. So you can see the prompt right here that we're just passing through. And you can actually see that on the back end side of things, we've retrieved 5 embeddings or documents, chunks of documents that pertain to that particular question. And then we're going to use that now to invoke MCP, which you see right here. And on the MCP side, you can actually see that we have invoked KHGPT to analyze for pod information. And then we've also executed just some stuff to get pod information or for normal Kubernetes stuff so that we can actually get the raw pod information for what's running in the cluster. That information from MCP gets rolled back to the agent. It applies our RAG embeddings so that it has that knowledge of what the NSA playbook is to come up with the answer to our particular question, which in this case is pass. So here's the summary. No workloads were found with that particular escalation or context. Number of problems found 0. Here's the compliance status. Here's the reference information for best practices according to our documentation, and like it's just giving you some YAML. I guess there was some example YAML within the runbook to like what this would look like if you found it in the wild. And here are the 5 chunks, right, of the vector embeddings that referenced, that was semantically similar to our prompt. And you can see all of the tool calling on the back end side of things. And so this is an interesting way, proof of concept, to how you could apply your own business rules or your own practice based on your runbook to an LLM, and then invoke whatever you want to discover about your Kubernetes cluster.
Awesome. So I think demo was pretty smooth, right? Everything worked pretty fine. I'm really glad with that. He's very good with presenting the demo. That's why I asked him to make sure he gives the demo. He's quite very well doing in the demo. Okay, so we talked about how we do that. We did the live demo as well. We also gave you the open source repository which you can go and check out, and if you have any questions, feel free to reach out to us. But here is the thing. I think now we did the demo, there is one question at least coming in my mind, which is like, what about the security? What about if we are using a model, it comes with like, doesn't it have the access to our cluster? Is it good or not? Can it make changes in our cluster? What about the credentials? Does it have access to our credential? What about the practices? If we are using the OpenAI model, does it have access to our private credentials or the practices that we are using in our organization? So I will ask David, what do you think about that? How do we tackle the security part of this particular case?
For this demo, for simplicity reasons, we chose like an LLM in the cloud. If you actually had security context and concerns in mind, you'd probably use a local LLM. And KHGPT does support using a local LLM. And the LLM that I use to drive the MCP endpoint and the RAG implementation, you could use that same LLM in both of those separate processes, right? So that would be a good way to bite off the security issues.
I think that would be a great idea. And as David mentioned, that it's a proof of concept. We are also still exploring, and there is a concept KHGPT have, which is of the guardrail. Does it help? And what do you think about that?
I mean, my opinion on guardrails is that they're a good first line of support for like trying to get people to that are misbehaving and using LLMs to get things that they're not supposed to be doing. I think it's a good first line support. But with any kind of security hardening, look to your organization's best practices for like AI security hardening. It's going to be very different and wildly different from using traditional like Kubernetes security hardening. So just understand that when you expose your workloads to AI, to AI and large language models, that you understand like the data that's coming in and out of that system at all points, whether it's through KHGPT or it's your RAG pipeline, and understand like how you harden that kind of infrastructure from the AI perspective.
Thank you, David. I think that's all from my side if you have anything to say, but yeah, that's all from my side. Thank you for joining us, and I hope you enjoyed the demo. We are up for the questions if you have any questions to ask.
Yep, we have 7 minutes for questions.
Thank you. Yep.
I guess there's a mic here. I don't know if you want to line up or whatever.
But before I think people leave, maybe would you like to take a picture? I want to take a selfie. Let's take a selfie.
All right, selfie, here we go.
Thank you so much, everyone. We are up for the questions. If someone have any question, would love to take the question.
How can I combine an MCP, KHGPT, and RAG to create a self-service portal for my developers to ask questions about best practices? I understand that Runbook is great to make sure you're doing security, configuration, but if I have a developer who wants to know what's the maximum number of CPUs, limits on PVCs on a namespace, et cetera, how can I take those 3 things and make that available to them?
Yeah, so with any kind of RAG pipeline, what you can do is this doesn't have to just support that runbook. You could have, and actually the code does, if there are any other documents in that docs folder, if you have any other materials or information about how you need to operate your Kubernetes cluster, what are the best practices, these are the limits, even just normal Kubernetes documentation, there's nothing to preclude you from being able to take that documentation and putting it in that docs folder and generating in vector beddings to answer whatever questions are related to those particular things that you're ingesting to your pipeline.
Awesome, thank you, I appreciate it.
Hi, oh man, I'm small. So question about the MCP with the RAG. What's the difference between doing that and, for example, using Markdown with an agent where it can pull an empty documentation for let's say I copy paste the document, right? The PDF, grab it, put it in a text and an MD somewhere, and it can just go get that as reference material versus using the RAG.
Yeah, so the RAG, the whole idea of the RAG pipeline, the RAG portion of it up front, is that you can, pull in information about your company and have it be reflected in the queries that you want to have it understand, to your organization, this is how my Kubernetes cluster should operate or behave, or how I troubleshoot it when something happens. There are many different ways you can go about, architecting a particular solution. This was just one that's pretty simple. It's vector embeddings, your LLM, which talks to an MCP server, and then that MCP server, you can expose many, many different functions or capabilities. So retrieve pod information, retrieve node information, retrieve cluster status information, retrieve security context, secrets, whatever you want to kind of expose. That MCP endpoint gives you the capability of being able to hook in the different tools that are available that are Kubernetes related to your LLM, right? And just understand especially if you're super security minded, that get operations are cool. You might need to partition that based on RBAC, right? And that's where your kube context, your kube control, per user will probably come into play. So you might need to stand up different MCP endpoints per user, and that's how you can start to do RBAC and access control and stuff like that. But yeah, it's definitely, this is a very simplified version of it, but there's nothing to preclude you from doing something like that.
Awesome, thank you.
Yep.
Hey, this is Dil. Thanks for sharing the demo. I'm also working on prototype, interestingly. So I'm working on creating an agent that talks to an MCP server using RAG, loading the PDF documents and using Kubebench and something like that. I'm also switching between open source models like Olama and OpenAI. Did you find any difference in terms of performance, latency issues? And also, how did you, what is the basis for your MCP servers and tooling? Is it existing tools, or did you write on your own?
So everything in the demo is code that we wrote fresh for this talk. So it's very limited. It's just to show you what is possible.
Okay.
And then in terms of your LLM, it really just depends on what you're comfortable with. If you could use a large language model, and you could.
I was switching between the two, but I see latency issues and also performance issues.
Exactly. So you could have latency issues. You could have. If you're going to run a large language model, it requires a GPU.
Yeah.
Yash works at DigitalOcean. I would highly recommend doing that for sure, if you need it for all your GPU needs. But if you need to run a small language model, right, you could do that, right? As long as that small language model is good enough to meet your needs. Plus, you're using the RAG portion to generate embeddings to impart that knowledge on your small language model. So there's no reason why you couldn't do that, right?
Sure.
So using Llama 3.1 8 billion parameter kind of a thing.
Yeah, that's what I'm doing. And one last question is, so I'm also trying, did you consider once we found the issue, the agent can go ahead and fix it? Once we confirm, go ahead and fix it?
It could, just be aware. I would probably be maybe a little uncomfortable. I think
with humans in the loop, though.
For me, this is where we're talking about the considerations, right?
Every LLM or model have that 1% or 2% of hallucination part.
Yes.
And I don't want that thing to do anything bad with my cluster, right? So there will be always a hallucination part, and we can't. I don't think so. I'll be fully relying on
Not fully, like with humans in the loop, for sure. Yeah.
Yeah, if you're doing humans in the loop and the operation's destructive, I would always 100% recommend that someone's there to push a button to say yes or no,
Yeah.
right?
Absolutely.
Yep.
Yeah. Thanks. Thanks
Yep.
a lot. Appreciate it.
And I think we have 1 minute, which is the last question.
Yeah.
Hey, great presentation. I contribute a little bit to KHGPT and also its Backstage plugin. So I have a question. Why did you guys choose to go the route of RAG or create embeddings in the first place? Because you can directly inject the context in the LLM context window. It's like 1 million tokens. So unless your runbook's like 5,000 pages, you don't need to generate embeddings in the first place.
Maybe that's a little bit more involved question, and I don't think we have the time to answer it up here on stage, but we're happy to meet outside to take any other questions we couldn't get to.
Sounds good.
For sure.
Thanks.
All right, thank you.
Thank you, everyone.
Can I squeeze in one?